Hey, welcome to on Real. Today, what we are going to learn about is about email generation using GAN. This is GAN. You will know later. This tutorial is from the Pytorch. Author of this tutorial is Nathan. Now watch. In this tutorial, there is code. We will explain. I'll explain it later. And there is explanation about how this code works. It is a complex explanation possible for how the uh, how the working function of the model or how the architecture is made, how it contribute to the image generation. Yeah, this is given based on this explanation. Let's get started. This tutorial will train the GAN. Is what is GAN? Generative adversarial network to generate new celebrities after showing the picture of the many real celebrities. Yes, we'll talk about the example by the Python example later. And first, let's talk about what is GAN. That means what is generative adversarial network. GAN are the framework for teaching a deep learning model to capture the training data distribution. You should know that capture the training data distribution. Point is here is distribution so that we can generate the new data from the same distribution. GAN were invented by the Ian Goodfellow in 2014 and first described in the paper Generative Adversarial Net. They are made of the two distinct models, a generator and a discriminator. From this word again we can describe the generator is function of generator is from the fake image that look like the training image, and the discriminator is to look at the image and output whether it is the real image or the fake image from the generator. During the training process, generator is constantly trying to improve itself by outsmarting the discriminator by generating better fakes, while discriminating is also working to become the better detecting and correctly classify the fake and the real image. The equilibrium of the game is where the discriminator can distinguish between the real image and the fake image. That is, it has case of the 50% confidence. That means 50 means 50-50 chance. It cannot distinguish between the real and fake image. Let us describe some notation. Some mathematical principle. It will help you better understand how it works. Let x be the data representing the image. X be the data representing image. Dx means what is it? D means the discriminator function. Dx is the discriminator network which outputs the probability that the x is come from the training data rather than the discriminator, rather than the generator. This dx simply gives the probability whether the given image is the real image or fake image. Since we are dealing with the image, the input size of the input size of the x is in CSW. Means first comes the channel size, then comes the height and width. If we are working in the other platforms such as the TensorFlow, you are doing the image size is slightly different, because in the TensorFlow there is the first height and width, and at last there is the channel size. In Tensor in Pytorch, the combination of channel height and width is slightly different from the TensorFlow. Intuitively, dx will be high as possible when x comes from the real image, means real means training image, and low when it comes from the generator. Dx can be thought as the traditional binary classification because it is generally distributed whether the given image is real or fake. If it is real, then 1. If it is fake, then 0. Between the because there is only a class, real or fake, it can be thought as the binary classifier. For generative notation, let Z be the Latin space Latin space means Latin vector space means what is the original distribution we are giving to the noise. Original noise distribution given to the like given so that we can generate the image. So simply here is said let's generate the Latin space vector sample from the standard normal distribution. Here from the main point you have to all remember standard normal distribution. That is in this sample from the standard normal distribution, not from the uniform normal distribution. If you are doing uniform normal distribution, the result you may expect is not what you want. Standard normal distribution means bell size curve. In the bell size curve, you are taking the sample space from the bell shaped curve, and GZ. G means generator. GZ represents the generator function which maps the latent space to the data space. Means we are working with the latent space Z. We are mapping the our noise to the data space. Data in our case, data space means the image vector, which is of the same size of the training data for the better performance and for the better dealing with the image and for better mapping. We are the data space is the image shape. The goal of G is to estimate the distribution of the training data comes from the P data so that it can generate the fixed samples from the estimated distribution PZ. Means we what are it, the goal of Z is so simple that it is to estimate the distribution of the using the latent space Z to map into the distribution from the training data so that it can generate the fake image itself. So DZZ GZ means it gives the image, and we are going to we are applying the D function in the outcome of the generated function gives the probability distribution that the output of the generator is the real image. As described in the good fellow paper, D and Z play a min max game where D tries to maximize the probability that it correctly classifies the real or fake image, and Z tries to minimize the probability distribution will predict its output are the fake log of 1 minus d z z. And from the paper, GAN loss is minimax dz. Here is the equation of the E data log d of x and plus ez log 1 minus d of generated image of the image. If you are look this equation carefully, you can see that it resembles the if you are if you have read the logic regression of the binary classification, it resembles the function of that binary classification problem. Find the loss function of the binary classification problem. We'll discuss it later. In theory, the solution to this mismatch is that PZ is equals to P data and the discriminator guesses randomly the input are the fake or real. That means generator generates so much alike the training data set that the model cannot distinguish between the generated image and the real image. And however, the convergence theory of the GAN is still being heavily researched, and reality model do not point always train to the point. You now comes the decision. Our main topic of decision. What is decision? It is the extension of GAN, generative adversarial network, except it explicitly uses the conventional and convolutional transpose layer as discriminator and generator. Means it uses the CNN network explicitly. It must use it when CNN uses the CNN networks in discriminator and generator. It is called decision. It was described as the Radful at L in paper you unsupervised representative learning with deep learning